Now let's try to go over some problems involving the sum of an arithmetic progression. We are going to be starting with some simpler ones, then gradually we will be proceeding to the most difficult ones. So try to stick with the video right from the beginning all the way to the end. So let's begin with the first problem, and here it is. The first term of an AP is 25 and the third term is 19. Find the number of terms in progression if the sum is 82. So let's try to handle this problem. So according to the problem, u sub 1, which is the first term, is 25. That's typically A. The value of A is 25. Okay, let me try to use white color. So the value of A is equal to 25. Perfect. And the third term, that's u sub 3, that's equals to 19. So we have to find the number of terms, that's the value of n. Okay, if the sum is 82, if the sum is 82, so therefore s sub n will be equals to 82. So our main goal is to find the value of n. Now, according to the question, I'm emphasizing on this. They said u sub 3 is 19. But according to the general term of an AP, u sub n is typically the first term plus n minus 1, then d. Since n is equal to 3, so this should be a plus 3 minus 1 d. So in the end, it should be a plus 2d. Perfect. Now, what we are going to do next is that we are going to solve for d by substituting the value of a as 25 in this u sub 3. So the u sub 3 is indeed 19 according to the question. So 19 will now be equals to 25 if we replace a with 25 over here. Okay, so we should end up with 2d. So I would like to subtract 25 from both sides, and I should have 19 minus 25 to be equals to 2d, because 25 of the right hand side cancels 25 and the left hand side, right hand side, okay, they cancel each other. So now 19 minus 25, that should be 6. Okay, so if I should have 6, so I should have minus 6 to be equals to 2d. The next is that I would like to divide both sides by 2. Okay, and in the end I should get the value of d to be equals to negative 3. So this is the value of d. Alright, now having gotten the value of d, likewise the value of a, and also at the same time s sub n is given to me, I can use the formula of the sum of an AP to get the value of n. So how is that possible? Here's what I'm saying in excess. Since s sub n is given as n by 2, then multiply by 2a plus n minus 1d. And out of all these 4 quantities, we have 3 of them. So definitely we can solve for the last unknown quantity. So s sub n is 82 according to the question. Is it over here? And the value of n is what we are trying to solve for. Then, so I have 2 multiplied by 25, since the value of a is 25. Okay, perfect. Then plus the value of n still unknown, minus 1, then multiply by d. The value of d we got is negative 3. Perfect. So simplifying further, hopefully I can get rid of this now. Thought you are waiting that. Okay, alright, fine. Now I should have 82 to be equals to 82 is now equals to n by 2, and multiply by 25 times 2 is indeed 50, plus n minus 1, and multiply by negative 3. So what I would like to do next is to distribute this negative 3 into whatever we have in the bracket, and also I would like you to bring this 2 to the side. So that should have 82 multiplied by 2 to be equals to n, and multiply by 50 plus negative 3 multiplied by 3 should be negative 3n, So let me just put it this way: negative 3n, negative 1 multiplied by negative 3, so that should be positive 3. Alright, perfect. So 82 by 2, what would that be? So let me try to type that into my calculator. Okay, so as to avoid any error. So 82 multiplied by 2, that's 164. So on the left hand side, I have 164 to be equals to n multiplied by 50 plus, or it should not be negative, okay? When I use the positive sign to expand the bracket, minus 3n plus 3, okay? What I did was that I used the positive sign to expand the bracket. So let's try to simplify more further, okay? Fine. Okay, okay. Now I have 164 to be equals to n, and multiply by 50 plus 3. Since they are like terms, they are both constant value, so you can definitely add them together. So I should have 53 minus 3n and close the bracket. And what I will do next is that I'm just going to expand the bracket with the n outside the bracket. So this should becomes 164 equals to 53n and minus 3n squared. So what I'm doing next is that I'm just going to subtract 164 from both sides, okay? Or let me just try to avoid negativity. So let me just put everything over to the side, okay? And I should have 3n squared minus 53n and plus 164 to be equals to 0, okay? Now it turns out to end up having a quadratic expression. So to get the value of n, I would like to use the quadratic formula so as to make our work easier and faster. So I'm trying to use the quadratic formula. So the value of a is 3, the value of b is negative 53, and the value of c is 164. Okay, so therefore the value of n will be equals to minus, in fact, minus 53, then plus or minus square root of minus 53 squared, and minus 4 times 3 times c, which is 164, and all divided by 2 times 3. Okay, so here's how the arithmetic formula is. It actually says that the variable you are solving for, okay, that's equals to minus b plus or minus square root of b squared minus 4ac and all divided by 2a. So that's how the formula is. Well, if you are not familiar with it, you can check out the video that just pop out, or try to check out my algebra playlist. You will find everything about quadratic equation over there. Okay, so now what I will do next is that I'm just going to simplify to get the value of n. Alright, now what could that be? Let's see. Okay, so I should have the value of n to be equals to, by the time I multiply this, I should have positive 53 plus or minus square root of what about 53 squared? What would that be? So let me put that into my calculator. So that's 2,809. Okay, we are subtracting it from 4 times 3 times 164. That's 1,968. And we are dividing 2 by 2 times 3, that's indeed equals to 6. Perfect. Now what we are going to do next is just to subtract the value we have within the radical. So in the end, oops, that was a mistake. N will be equals to 53. Okay, 53 plus or minus square root of what exactly is the value of 2,809 minus 1,968? So that's 841, 841, then everything by 6. And lastly, we should have 3 plus or minus square root of 81 is actually what? That's 29, so 29, then all divided by 6. Hopefully you can see that. So the value of n will be 53 plus 29 divided by 6, or 3 minus 29 divided by 6. So in the both cases, what we have, let's see. So n is 53 plus 29 divided by 6. 3 plus 29. 3 plus 29 by 6. That's 13.6. Well, this can never be the value of n because it can be a fraction and it can be a decimal value. So we have 13.6. So 53 minus 29 divided by 6, that's 4. So we would like to go for 4. So the sum of the first fourth term is what gives us 82. Okay, so forget about this solution. The value of n cannot be that. Alright, it must always be a whole number, and that is the solution to this problem. Okay, let's try to solve more problems. The fifth term of an AP is 23. The 12th term is 36. Find the first term, the common difference, and the sum of the first 11th term. Okay, let's try to figure out how the quantity is given to us. So according to the question, the fifth term, which is u sub 5, is 23. The 12th term, that is u sub 12, is 37. Okay, so we need the first term. We need a common difference. Then we need s of 11. Now let's try to find the value of a and d respectively first. So after that, we cannot get the sum of the first 11 term. Now, according to the general term of an AP, u sub 5 would be a plus 4d. I'm just trying to be precise. What I'm trying to do in sense is that I'm trying to use this formula. Okay, so you just need to subtract 1 from n, multiply the value with d, and add it to the first term. So this should be equals to 23, and u sub 12 should be a plus 11d, and this will be equals to 37. Perfect. Now we have two systems of linear equations, and to solve them, we need to use simultaneous concept. We need to use simultaneous equation. So let's try to use elimination method. I recommend the method as this easier and faster to use. So I would like to subtract equation 1 from equation 2. Okay, let me just put the expression sign between them and put it like this: equation 2 minus equation 1. Okay, that's the meaning of the statement. I mean, subtract equation 1 from equation 2. Alright, fine. Now a minus a becomes 0, and 11d minus 4d, so that should be 7d. Okay, if I'm not mistaken, 7d to be equals to 37 minus 23. What would that be? Okay, let's try to use my 37 rather. 37 minus 23, so that's 14. So I have 14. So the next is to divide 3 by 7. I've got the value of d to be equals to 2. Okay, so you jot that down somewhere as we'll be needing it as we proceed forward. Now, having gotten d, the next thing is to put the value of d as 2 in equation 1. So equation 1 turns out to be a plus 4d to be equals to 23. So if d is 2, I should have a plus 8 equals 23. And if I subtract it from both sides, I should get the value of a to be equals to 20. Okay, sorry, that's wrong statement. So 23 minus 8, 23 minus 8 is 15. So the value of a will be equals to 15 and not 20. Okay, so be very careful. This is exactly what it's trying to convince you. So it is 3, not 8. Okay, it's 3. Alright, 23. Perfect. Now we have the value of a, likewise the value of d. Now it's easier for us to get the value of the sum of the first 11th term. Okay. So let me try to get rid of some stuffs. Alright. Now we know that s sub n is equals to n by 2, then multiply by 2a plus n minus 1d. Perfect. So we know that the value of a is 15, d is 2, n is 11. Now it's easier for us to get s sub 11. So I have 11 by 2. What I'm trying to do is that I'm just trying to substitute 15 plus 11 minus 1, then multiply by 2. So what would this be? 11 by 2, then multiply by 30 plus 20. So I should have 11 by 2 multiply by 50. This counts 25. So what exactly is 11 multiplied by 25? So that will work 25 times 11. That's 275. So s sub 11 is 275. And this is the final solution to this problem. Hopefully you're now getting familiar with how the sum of an AP works. Okay, perfect. Let's try to go over many problems. Round 3. Prove that the log of AR, log of AR squared, all the way to infinity are in arithmetic progression, whose sum is half of n multiplied by log of a squared r raised to the power of n minus 1. Now, if this sequence is going to be an arithmetic progression, if it's going to be an arithmetic series or progression or sequence, there must be a common difference. That is the only thing that differs arithmetic progression from any kind of progression. There's always a common difference that differs the preceding term from the preceding term. So once we can figure that out, then the particular sequence or series is an arithmetic sequence or series. So let's try to figure out if there's going to be a common difference. Now let's begin. Now there's one more thing. We know that to get the value of d of a arithmetic progression, what we need to do is just to subtract the first term from the second term, or the second term from the third term, or generally speaking, the preceding term from the preceding term. Perfect. So we are going to run a test in two cases. So let's get the value of d by subtracting the first term from the second term. We know that u sub 1, which is equals to a, is given to us as log of a. U sub 2 is given to us as log of ar, and u sub 3 is given to us as log of ar squared. Now the value of d is equals to u sub 1, also u sub 2 minus u sub 1. So what would that be? So that should be log of ar minus log of a. Perfect. Now what exactly is that? I think at this point we will be needing some of the identities of logarithms. Whenever two logs are subtracted each other, you can take one of the log and divide their value. Okay, so this is the same thing as log of ar divided by a. Perfect. And what we are going to observe is that a cannot cancel a over here, and in the end we have log of I. Okay, fine. Now, if D is log of I, let's try to confirm this. If we subtract in another way out, we know that D can also be equals to U sub 3 minus U sub 2. So if this gives us log of I, then definitely a common difference exists. And once the common difference exists, then the particular progression is an AP. So this is log of AR squared minus log of AR. So just like before, this becomes log of AR squared divided by AR. Wow. So if AR cancels one AR, we'll be left over is log of R. So therefore, common difference exists. Then this is an arithmetic progression and not geometric progression. Perfect. Now, having gotten this, we can proceed to the next one, which says that whose sum is half n multiplied by log of log of a squared and r is power n minus 1. Now that you have the value of d, the value of a, you can just plug it in for you to testify to it. Okay, so don't forget to write it down. The value of d is log of r and the value of a is log of a. Perfect. F sub n of an AP is n by 2 multiplied by 2a plus n minus 1 d. Perfect. So what I will do is that I'm just going to substitute the value of a and d respectively. N by 2, then 2 times log of a. Don't forget, the first time is log of a. Perfect. Plus n minus 1. Then the common difference we got earlier was log of r. Now, another identity of logarithms is that if a logarithm to a particular base, let's say a, of a particular value, let's say b, such that b has an index r, then the r is allowed to come to the front of the logarithms. And this can also be done in the vice versa way. If the r is already in the front of the logarithms, it can also come back to be an index of b. So we are going to be applying this right now. So this will become s sub n equals to n by 2. Then 2 log a plus n minus 1 log r. And I would like to bring this to the front and bring this up. And so I have n by 2 log of a to 2 plus log of r to n minus 1. And the last identity we are going to be applying is that when two log are summing each other, you can take one and multiply their stuff, multiply their valid identities. S of n equals to n by 2, then log of a squared, then r to the power n minus 1. Just try to correspond to this. And therefore, the statement has been proved. And this is also the final solution to this problem as well. Now, try to pause the video and try to check out this next problem yourself. Don't forget, practice make perfect. If you haven't subscribed, pause the video now and subscribe to my channel. Thank you. The sum of the nth term of a particular series is given by s sub n equals to 7n minus 3n squared. Show that the series is an AP and find the first term and the common difference. Now, to solve this problem, you can actually do this in two different ways. But the best one and the easiest one is what I'm going to be showing you here. Now, keep in mind, it's just straightforward. Okay? And that is by finding or figuring out if at all there is a common difference. Once there is a common difference, then the particular series is an AP. Now you might be wondering that how do I want to know if there's a common difference with this only quantity given to me? Now there's one thing I want to show you. If you have, let's say, a certain progression, typically it's an AP. So if you're going to put an AP, let's consider an odd number, 1, 3, and 5. What exactly is S sub 3 of this AP? It means that S sub 3 of this AP is just going to be 9. Now what about S sub 2? What's going to be S sub 2? S sub 2 is also going to be 4. Perfect. Now, what have we observed? Now just notice that the difference between S sub 3 and S sub 2 turns out to give U sub 3, which is what? Which is 5. So typically that's 9 minus 4, which is indeed equals to 5. So a general conclusion we can make is that U sub n is equals to S sub n minus S sub n minus 1. Why? Because S sub 3 is this, and S sub 2 is S sub 3 minus 1, and gives U sub n, which is U sub 3. Perfect. This is a particular or another formula you just need to keep in mind. Okay, you just need to put that in the back of your mind as you might be using it in different ways. Perfect. Now another one I want to show you. Well, you might already be familiar with that. You notice that the value of d is also equals to U sub n minus U sub n minus 1. Okay, that's exactly the common difference. Now, I'm already given S of n in this problem to be equals to 17n minus 3n squared. Perfect. So I haven't gotten this, then definitely there's a way to solve this problem by figuring out if d is present, if d occur or not. I'm just going to solve for S of n minus 1 to get U sub n. I haven't got U sub n. I'm going to solve for U sub n minus 1 to get the value of d. So let's begin with no time. Oh, sorry. Alright, so if S sub n is equals to 17n minus 3n squared, then n sub n minus 1 will be equals to 17 multiplied by n minus 1 minus 3 multiplied by n minus 1 all squared. Perfect. So let's simplify n S sub n minus 1. So if I distribute 17, I should have 17n minus 17. What I did was that I expand this bracket. Okay, perfect. Now I should have minus 3 multiplied by. So let's expand n minus 1 all squared. So if I have n minus 1 squared, that's n minus 1, n minus 1. That's n squared minus 2n plus 1. Perfect. So I'm just going to replace it with that. Okay, n squared minus 2n plus 1. Fine. N squared minus 2n plus 1. Good. Next, I would like to distribute negative 3. So expand the bracket. So I should have 17n minus 17 minus 3n squared plus 6n minus 3. Perfect. So is there any like terms? Here it is, this and this. Fine. So S sub n minus 1 is minus 3n squared, then plus 23n, then minus 20. Perfect. Now, I said it earlier that U sub n is equals to S sub n minus S sub n minus 1. Okay. Now, what I'm doing next is that I'm just going to get rid of this like this, because I just want everything to be straightforward and easier for you to identify. Then what I'm doing next is I'm just going to bring this up. Okay. Sorry. Alright, so let me just shift this up a little bit. Alright, fine. So we should have use of n equals to 17n minus 3n squared, then minus, so we're gonna put it in a bracket, since this not more than, since this a trinomial is more than one term, so minus 3n squared plus 23n and minus 20. And if I distribute the negative sign, then we should be left over with plus 3n squared, then minus 23n and plus 20. Perfect. So if I subtract 17n from negative 23n, so I should be left over with negative 6n minus 6n. Then this cancels out. Perfect. Then plus 20. Perfect. So use of n is negative 6n plus 20. Good. Now if use of n is that, then I can get the value of use of n minus 1. Alright, hopefully you are following. So we got use of n to be equals to negative 6n and plus 20. So what would now be use of n minus 1? So that becomes negative 6 multiplied by n minus 1 and plus 20. And in the end I should have negative 6n plus 6 plus 20. And I should got negative 6n plus 26. Now I notice that the common difference is equals to use of n minus use of n minus 1. So therefore this becomes negative 6n plus 20 and minus in bracket of negative 6n plus 26. Okay, so this is 26. Don't confuse it with 20. Alright, so the value of d now becomes negative 6n plus 20 minus, plus 6n, then minus 26. Perfect. So negative 6n can cancel plus 6n plus 20, negative 6, that's d equals to negative 6. So the value of d is negative 6. So it means d is present in the particular series. So therefore it is an arithmetic series. Now the next is to what? Is to find the first term. So now to get the first term, we will be needing this, like we'll be using this formula to get the first term by just substituting 1 as n. The first term is when n is equals to 1. So that can help us to get the value of a. Okay. So therefore, use of 1, which is equals to the value of a, which is equals to negative 6 multiplied by 1 plus 20. And that should be negative 6 plus 20. And that should be positive 14. So that's 14. And this is the value of a. And this is also the final solution to this problem. By now, you should have developed your ability in solving some of an AP problems. The last problem for this video. In an AP, u sub 10 is equals to 3. That's the 10th term. And the sum of the first 6 terms is 76.5. Find the value of a, the value of b, and the smallest value of n, such that s sub n is less than 0. So I changed my mind. That will be an exercise for you. Try to solve it using the basic knowledge and the ideas we have discussed earlier. If you have any question, feel free to ask it in the comment section below. And you have the freedom to post it in the comment section with your solution. So I'm going to make a review on it and respond to you. Thank you once again. See you guys in the next video.